fast. I could roast, I could gas, think I'm okay at last, but I don't know if that can erase all the past and the pettiness, a reflection of the emptiness.
Welcome to this video on CyberArk and Azure. We will provide an ultimate integration guide focusing on the Cloud Privileged Access Management, or PAM, strategy. Let's look at the privileged access problem and why CyberArk is needed. Unmanaged identities are a major issue, as 80% of breaches involve compromised privileged credentials, which are widespread in the cloud. What is CyberArk? It is the global leader in privileged access management, providing a comprehensive identity security platform. It acts as a secure digital vault, managing and monitoring privileged accounts across the enterprise. The core components of CyberArk include the Enterprise Password Vault, or EPV, where secrets are stored. PVWA is the web interface. PSM, the Privileged Session Manager, isolates and records sessions, and CPM automatically rotates passwords. CyberArk helps in breaking the attack chain. It prevents credentials from being stolen, as they are not on endpoints. It also blocks lateral movement through session isolation, preventing attackers from jumping between servers. Enhancement mechanisms include credential rotation, such as one-time passwords and exclusive access, and session isolation. The air gap means users connect only to the PSM proxy. Users never see the password, preventing leaks. The advantages extend to business and compliance. CyberArk facilitates audit readiness with detailed reports. Session video recordings provide irrefutable forensic evidence, and having PAM can help with cyber insurance qualification and lower premiums. Technical and operational advantages include automation, eliminating manual password management across various systems. It offers seamless integrations with tools like Splunk and ServiceNow, and provides broad support for systems from mainframes to Kubernetes. Challenges include complexity, requiring dedicated infrastructure and skilled personnel. Cost can be high for small to mid-sized businesses, and user friction is common as it changes admin workflows. The integration of CyberArk and Azure allows for securing the hybrid cloud. This extends the security of the vault to the elasticity of the cloud environment. The integration architecture requires the CyberArk Vault to reside on-premise or in a secure VNet. Component servers interact with Azure APIs, and an Azure Service Principal acts as the identity for CyberArk actions. Integration Step 1 covers prerequisites. CyberArk needs permission to manage Azure, which is achieved through Azure App Registration. This involves creating an app registration, generating a client secret, and assigning necessary API permissions. Integration. Step 2 details discovery and onboarding. After inputting Azure credentials into the vault, a discovery scan targets the Azure subscription ID. CyberArk detects and lists accounts, automatically importing them for password rotation. Scenario 1 is secure console access. An admin logs into the CyberArk PVWA, finds the Azure account, and clicks Connect. CyberArk opens the Azure Portal and injects the password securely, enforcing zero trust. Scenario 2 addresses application secrets. The problem is hard-coded client secrets in developer code. The solution is Application Access Manager, or AAM, which allows the script to request credentials securely at runtime. Scenario 3 is just-in-time, or JIT, VM access. Instead of permanent admins, CyberArk provisions ephemeral, temporary users on the Azure VM only when access is needed. The user is automatically deleted after the session window, ensuring zero standing privileges. Key takeaways include the importance of centralizing all identities in a single vault, isolating connections to stop lateral movement, and automating credential rotation to render stolen data useless. Thank you for watching this video. We can now open for questions and answers.